So here we are going to study how to convert the rectangular form of complex numbers into polar form. So all of us have the idea what are the complex numbers. The numbers that have the real and the imaginary part are said to be complex number. The rectangular form can be written in the form of z equals to a plus bi, where a represents the real part and the bi that represents the imaginary part of the complex number. We can also write it in the form of z equals to x plus yi. So in both the cases, we have the coordinates. In the Cartesian form, we have the coordinates x and y. So when we use to represent the complex number of the rectangular form, we use an argent plane to draw or to sketch those numbers. And on the argent plane and in the argent plane, the x represents the real part and the y represents the imaginary part. Now we are trying to convert the rectangular form into polar form. Now, first of all, it is very important to understand that why we are studying the polar form. So, the polar coordinates are used often to navigate the destination or the direction of the travel, which includes that you must know the direction or the distance of the object, and also the direction of the object must be known to you. Now, the distance can be found by finding the r or the modulus of the z, the same way as we found in the rectangular form. And theta, it is the argument. It is the argument that is used to navigate the object. We have to see that whether the object is moving clockwise or anti-clockwise. So that's why we use the theta, and theta is said to be argument. Now later on we will just focus what is argument. Now before solving anything, it is very important to understand and to just recall the trigonometric ratios. So if I have a right angle triangle, you know that the horizontal distance, for example, it is termed as x, and the vertical distance it is y. Okay, so the longest part or the longest leg, it is said to be the hypotenuse. And let's suppose the hypotenuse is represented by the z, or the absolute value of any complex number or any number. Okay, now basically in the real part we always use the word r for it in a unit circle to represent it, and if you want to represent it with the absolute value of z, no harm in it. Now x can also be represented by the a, and y can also be represented by the b. So it's up to you. So but the basic thing is to understand the idea. We all know that there is a formula of sine theta in the trigonometric ratios. We have the three basic trigonometric ratios, that is the sine theta, cosine theta and tangent theta. Now sine theta, it is opposite over hypotenuse, whereas cosine theta, it is adjacent over hypotenuse, and tangent theta, it is opposite over adjacent. Now let's see, also the tan theta is also be known as sine theta over cosine theta. So this is also the formula for the tangent theta. So if here is the theta, this is the angle. So the opposite is the y. Okay, so this is the y. So opposite is y. And the hypotenuse, let's suppose we are representing by the r. Now the cos theta is adjacent over hypotenuse. So this leg is said to be the adjacent leg, which is equals to x, and the hypotenuse, as we just say, that it will be represented by the r. Okay, and the tangent theta can be sine theta over cosine theta or opposite over adjacent, and we know that opposite is y and adjacent is x. Now let's understand, if from this formula, that is sine theta equals to y over r, can I find the value of y? Yes, of course. How can I find the value of y? I bring the r on the other side by the cross multiplication and I will get r sine theta. So this is what I need. Now I have the second formula, that is cosine theta equals to x over r. So in order to determine the value of x, I bring the r on the other side. So it will give me r cosine theta. So come to the rectangular coordinates or the normal coordinates or the Cartesian planes coordinate, that is x and y. So can I write the x as r cosine theta, which I just found out, and y can be replaced by r sine theta. So this is what we already have studied. Now the tangent theta, it is equals to tangent theta over here. I am writing here with the green plan. Please have a look. Tangent theta, it is equals to y over x. Now from here, can I find the value of the theta? Yes, I can find it. How? To bring the 10 on the other side. So I must take the inverse of the 10. So 10 inverse. Don't say 10 to the power minus 1. That is wrong. It is said to be tangent inverse. And 10 inverse, automatically it comes as 10 to the power negative 1, but actually it is the way to represent the 10 inverse. Otherwise 10 inverse can be written as arc of 10 and y over x. So this is our theta, that is tangent inverse y over x or r10 y over x. Now, from the same right angle triangle, this is the right angle triangle, can we determine the value of the r? Yes, we can find out the value of the r by using the Pythagorean theorem that states c square equals to a square plus b square. So, rather than writing the c, can I write it as r? Yes, I can write it as r. So, r square equals to a square plus b square. In order to remove the square of the r, I will take the square root on the both sides and this square will cancel with this one. So what is the formula of the r which I concluded? I am writing here. So r equals to square root of a square plus b square. So as in the beginning we said that for the polar coordinates, we need the two things, that is r and theta. So our formula for the r, it is square root of a square plus b square, and for the formula of theta, it is tangent inverse y over x is prepared. Now let's practice, and before that one we will see that one more time, that in order to find the r, first of all understand this, that in order to change the rectangular form into the polar coordinates, we need the r and the theta. The formula of the r is square root of a square plus b square, and the formula of theta, it is tangent inverse b over a. Okay, now after this one, what is another thing which is very important to understand, that we need to understand that what are the reference angle and how can we write the ref angles in the coordinate planes. So first of all understand, this is the first quadrant in a coordinate plane. Here is the second quadrant, then comes third quadrant, and then comes as fourth quadrant. Now in pre-calculus, while solving with the polar coordinates, it is important that your calculators must be in radian mode. It means read all the angles in radians. So if if you don't remember how to convert the degrees into radians, then for example, from degrees to radians, it is important that whatever the degree, for example, a degree, you have to convert it into radians, so multiply by pi over 180. But if you have the calculator, go and press shift mode. When you press the shift mode, it will comes on the 4, it is written radian. You just press the 4 and your calculator now in radian mode. Why I am saying this all? Because our calculation must be in radian mode. Now this is 0 degree or 0 radian. Here it is pi over 2 or it is 90 degree. Now on this side it is 180 degree or it is pi radians. Now below the x-axis on this side we have the 270 degree or 3 over 2 pi. Now next comes again, that is 2 pi, so or it is 360 degree. So we are just trying to take you in a unit circle in order to find the theta, because the theta will show you that which direction you are moving. So in my case, I want you to write the theta between 0 and 360 degree or 2 pi. So this is my theta, and for this one I'm trying to find out I'm trying to generalize my formulas. So anything comes in the first quadrant from 0 till 90 degree or pi over 2, whatever the answer comes, you will take it as it is. Now if you want to jump from the first quadrant to the second quadrant, use the formula pi minus theta. If you want to jump from the first quadrant to the third quadrant, use the formula pi plus theta. Now from the first to the fourth quadrant, better to write down 2 pi minus theta. So these are the formulas which you are going to find out your final argument or final theta. Okay, argument. In this way we can find out the argument in the polar coordinate, in the polar form. Now after this, the most important thing you must understand that this is the x-axis. So on this side the axis is positive, and above this is the y-axis. So on in the first quadrant the y is also positive. This is very important to understand about the sign of the coordinate plane, whether it is the complex plane or the Cartesian plane. Now we have in the second quadrant, this is the x. So x on this side are negative, and this is the y they are sharing, which is positive. Now in the third quadrant, x is negative and y is also negative. And what is happening in the fourth quadrant? In the fourth quadrant, this is our x, which is positive, whereas the y is negative. Now understand, it is very important that in the first quadrant, the real part is positive and the imaginary part is also positive. In the second quadrant, real is negative, whereas the imaginary part is positive. In the third quadrant, both are negative, and in the fourth quadrant, the x value is positive and the y value is negative. Why it is important? It is very important to see that where our theta is lying. If our angle is lying in the first and we want to find out or navigate it to the fourth quadrant, then we have to finalize our answer by changing it and writing the formula 2 pi minus theta. So this concept you will understand when we will try to solve some of the real life examples. So first of all, one more time, understand that the absolute value can be written as square root of a square plus b square, and to find out the argument or theta, the formula is tan inverse b over a. And in the end, the rectangular form can be written in the form of r cosine theta plus r sine theta I, or I would prefer if you write the r, then bracket, write down cos theta plus iota sine theta. So this is the best thing if you memorize this equation. R cosine theta plus iota sine theta. And what is R? R is actually the absolute value. So argument of a complex number, it is actually the angle inclined from the real axis in the direction of complex numbers. It means that the angle is telling you that where you are moving, and it should be in the radian form. So let's try and solve some of the questions to understand. The first thing the first thing you have to focus that which quadrant it is lying. So here the real part is positive and the imaginary part is also positive. So if I just draw here, so the positive and positive means the first quadrant is my actual focus. And here whatever the answer comes is my answer. So let's see how do we write. First of all, we will find our R. R means that the absolute value of Z. The formula is A square plus B square. So our A square is 4. Our A is 4. So write down 4 square. Then plus our B is square root of 3 and put the square. So you will get 16 plus 3, that is square root of 19. Once it is done, we have to find out our theta. So theta is equals to tangent inverse B over A. Now, what is our B? Tangent inverse. What is our B? This is our B, that is square root of 3. And what is our A? That is our 4. Now write in the calculator tangent inverse. So for tangent inverse, you will just press shift and tangent. Tangent is written near the sine and cosine. And then write down square root of 3 and then divided by 4. Make sure your calculators are in radian mode. So if I see here my calculator is in radian mode or no. So let's see, my answer is 0.408 or 0.41. Now I have my R, I have my theta. I have to change it into my rectangular form. So the rectangular form of 4 plus square root 3i can be written as R cosine theta plus iota sine theta. So my R is square root 19 and then cosine theta is 0.41 plus iota sine, and again the theta is 0.41. So that is all, and this is my answer. Let's check the another question. So here now let's check another question. So here first of all, your real part is -2. It means your A is -2. And what is your B? Your B is 4. Okay, now let's -2 and +4 means you have the negative x value and the positive y value. So negative x here and positive y over here, which means that you are talking about the second quadrant. Now hold on, okay, and first of all find out the R, which is actually the modulus of Z or the absolute value of Z. Make it as square root of A square plus B square. Substitute A and B, that is write down -2 whole square plus your B is 4 whole square. So here you will have 4 plus 16, so that is square root of 20, which will gives you 2 square root of 5. After that, what you have to do? you have to find out the theta. Okay, now in order to find out the theta, what we have to do, we have to write down tangent inverse b over a. b over. Now remember, if you want to avoid the errors, don't write the b and a in the negative form. Always take them as positive, because it will direct you to the first quadrant in the anti-clockwise, and you can move from the from worst quadrant to the required quadrant. So I would suggest take the 4 and the 2 with the positive sign. I hope you understood that whenever there is a negative number, you take it as positive to find out the angle. Okay, now write down tangent inverse. It means shift 10 and then 4 over 2, and that would give you 1.107, that is 1.11. Now if we find out the theta, this is on our first quadrant. So what you have to do, this is your theta. You have to find out the argument of z. For that reason, you have a formula in the second quadrant, that pi minus theta. So you write down the pi minus theta is this thing which you get it, that is 1.11. Now write in the calculator, and in order to write the pi, you know that shift and times 10 to the power x at the bottom. It is written just at the bottom of the calculator. This cursor lies at the bottom of the calculator. So pi minus 1.11, and it would give you 2.03. So here it will give you 2.03. Now the end r, you have to write it r cosine theta plus iota sine theta. So you just replace the r by 2 square root and 5, and then write down cosine as it is. In place of theta, you have to write down 2.03 plus iota sine and 2.03. So this is how we convert the rectangular form of complex number into the polar form. Let's solve one more question and see what is happening over here. So here the real part, it is -1, and the imaginary part, it is square root of 3. That means both are negative, and you can see that the x negative, y negative, it means they all belong to the third quadrant. So we have to use the formula pi plus theta. Now first of all, find out the r. That means find out the absolute value of z, which means a square, that means -1 whole square, plus b square, that means negative square root of 3 whole square. So it will give you 1 plus 3, that is 4, and it will give you 2. Now find out the theta. For that reason, I told you tan inverse and take the positive values of x and y. That means write down square root of 3 and write down 1. Please don't write the negative signs. Write in the calculator. Make sure that your calculators are in radian mode. Why I am telling and repeating this thing again and again? Because normally this is the error which our students do. So theta equals to tan inverse 1 over 3 pi. You have to jump to the third quadrant. So our argument of z, it is equals to theta plus pi. Now theta is what we got, that is 1 over 3 pi plus pi. So we will get here 4 pi over 3. Now write it down as the polar form. So r, that is r, and you will write here cosine theta plus iota sine theta. So r is 2, cos, and theta is 4 pi by 3 plus iota sine and 4 pi by 3. So this is how we found our answer. Let's practice what will happen if we have a number in the if we have a number in the fourth quadrant. So you can see the formula is 2 minus 2i, that 2 is the real part which is positive and the imaginary part is negative, and positive negative, they lie in the fourth quadrant where your formula is 2 pi minus theta. Now what we have to do? First of all, we have to find the r, that means the modulus of z. That means you have to take the square root of a square plus b square. So it is 2 square plus negative 2 whole square. Make sure that all the negative numbers are written within the brackets to avoid any mistakes. So it will be 4 and 4, 8. And it will be 2 square root of 2. Now find out the theta, which is tangent inverse of y over x or b over a, and you have to take the positive numbers of the b and the a, and it would give you tangent inverse 1. So find out please what is tangent inverse of 1. So it is, I guess, 1 over 4 pi. It could be as much as I remember. Yes, it is equal to 1 over 4 pi. Now your theta, it is in the fourth quadrant, so you have to find out the argument of c, which is equals to 2 pi minus theta, that is 2 pi minus your answer 1 over 4 pi, and it will give you 7. 4 times 2, 2, 8 minus 1, that is 7 pi over 4. So this is your argument of c. Now write down finally the answer, r cosine theta plus iota sine theta. Now r is 2 square root 2, then cosine, and our theta is 7 pi over 4 plus iota sine, and then again the theta is 7 pi over 4. So this is the answer.